All right, everybody, let's look at some new concepts that are really going to knock your socks off here. We have section 1.2 in the geometry book, and we are going to be talking about segment lengths and congruency and what that all means and how that can help us out. Going to be an important concept throughout the entire year. So here we go, starting with two definitions. We have our idea of postulate, we have our idea of theorem. Two very closely related ideas that are different for one reason and only one reason. So, a postulate is a rule that we accept without proof. And a theorem is a rule that we accept, I'm just going to use ditto marks for that part, with proof. So there are going to be a few ideas that we have that we're just sort of going to say, well, these have to be true. And if they aren't true, then everything that we're trying to do here breaks down. So we accept them to be true because if we didn't, all of geometry would break down and we'd be at kind of a loss for what to do with things. So we just sort of say, yep, these are things that are definitely true. So here are some examples, and we're going to go into what's going on with this exactly coming up in a moment. But first we're going to look at these examples. So what we have here is a request from the sheet. We need to find the length of km. Remember, that means that we're looking for the total distance that it takes to get from k all the way over to m, that entire distance. Well, if we know that k to l has a length of 24, and we know that l to m has a length of 12, then that should mean that if we want to get from k to m, then we would take the 24, we would take the 12, add them together, and that would give us a length of 36. Now you may be wondering, why are we doing this? What's the whole point? Why is that an important thing to know? Well, imagine if k, l, and m were cities, and you were looking to figure out how far you had to go on a trip. Well, then it would be a pretty important skill to be able to take these numbers and add them together and figure out what the total distance was of your trip. Otherwise, you may not be able to properly plan for buying gas or anything like that. So it's a pretty simple example, but it's important for us to be able to do this. Second example, let's say we want to find UV. Well, what is UV? That would be the distance between those 2 points, U and V. So we want that little segment right there. We're told from this information here at the top that going all the way from U to W is 56. We also know that VW is 45. So if we wanted to find UV, all we would need to do is take the 56 total and subtract out that 45 that we see VW to be. That leaves us with a length of 11, which is what UV has to be for this situation to work out. This last one, look at that, return of algebra, it's back. So, what are we going to do here? Well, if we know that the total, well, first of all, let's look at what we want to find. LM. There's L, there's M. So basically, we want to find what that length is. We want to find the value of x, and that will be the key. We know that the total length of the whole thing from L to N is 18. And what have we done with these previous examples? Well, in this first one, we took the 24 and we took the 12, and we added those together, and we got 36. We're going to do the same thing over here. We know that one segment, LM, has a length of x, and MN has a length of 2x. If we add those together, we should have the total length of 18. And now it's an algebra problem. If 18 equals x plus 2x, that means that 18 equals 3x. To get x by itself, we divide both sides by 3, and that gives us that x equals 6. We plug 6 in for x, and we see that LM has a length of 6 then. I could find MN, but I'm not going to because I wasn't asked to, and that's not important for me solving the problem I've been asked to solve. So these examples are all examples of something that is known as the segment addition postulate. And what that segment addition postulate says is that if B is between A and C, then AB plus BC equals AC. Putting that into English, remember that means that the length of AB plus the length of BC equals the length of AC. If we were to put that on a picture, that would tell us that if we had A here, B here, and C here, that if we took AB and added BC, we would get the whole length going from A to C. A pretty straightforward, true statement, I would say. So let's look at this example then. These two examples. So point G is between F and H, they tell us in example 2. So I'm going to draw that. We have F, we have H, and somewhere in the middle is G. It may be directly in the middle, it may not be. One thing to know about geometry pictures is they'll often not be completely accurate. They might be a little bit what's called not to scale. So if that happens, don't worry too much about it. All you have to do is look at the math that's happening. The picture may be a little misleading. Don't pay too much attention to the pictures. So we're told that FH, so that whole distance going across from F all the way to H, is 22. And we're also told that FG is 5, and we need to find GH. So we need to find what's left here. Like I said, this picture, a little misleading. It looks like that other one couldn't possibly be as big as it's going to need to be, but we'll figure it out. So, if the whole length is 22, we know that if we take FG and add GH, we should get 22. We also know that FG is 5. So if I subtract 5 from both sides, I find that GH should have a length of 17. And that would be our answer then. Now this case, example 3, is a lot like that last example we did before looking at the theorem. We know the whole length is 27, and we know that that has to be made up of the two parts that we have, which are 2x plus 3 plus 3x minus 1. If we add 2x plus 3 and 3x minus 1, we're going to get that 27 equals 5x plus 2. I subtract 2 from both sides to get 25 equals 5x, and I divide both sides by 5 to get that 5 equals x. Once we know that 5 equals x, we see we're looking for yz, which is this distance. So I'm going to plug 5 in for x there, and I'm going to get 3 times 5 minus 1, which gives me 15 minus 1, which gives me 14. And that's our final answer for that one. So you can see that these problems range from ones that use just simple numbers all the way up through problems that use variables. And you have to solve for variables, and then you have to plug that variable back in and find out what the length that you're looking for is. So these can definitely appear in different ways. So that's a really good thing for you to know. So I'm just going to erase a little bit of this. If you need to still write some of it down, please feel free to, and remember that you can always play the video back a little bit and see what's up here. All right, second topic for this notes, this one's actually even a little bit of an easier concept, is the idea of congruent segments. Congruent segments are segments with the same length. So the symbol for congruent is based on an equal sign. You just take an equal sign, and you put a little squiggle above it, basically. That's the symbol for congruent. Something to be aware of is that segments, since they are figures, since they are objects, are going to be congruent. But lengths, because they are numbers, are going to be equal. So congruency is basically equals, but for actual objects that exist. Whereas equal is when you're referring to just a pure number. Let's see this play out in an example. Okay, so we have to plot a few points. We have -4, 4, so this is point M. We have 2, 4, so 2, 4. This is T. I'm sorry, this is A. We have 1, 4, 1, 4. This one is T. And we have H, which is 1, -2. And there's H. And we're being asked to determine whether MA and TH are congruent or not. Now, we could use distance formula here, but I'd say that's kind of a waste of time because we can just count how long these segments are. MA, for example, so we have 1, 2, 3, 4, 5, 6 spaces, so a length of 6. And then TH, we have 1, 2, 3, 4, 5, 6 spaces. They're both 6. So, MA and TH are congruent. Now, if we want to say that they're congruent in this picture, you saw this a little bit earlier on a quiz or a test, or both, for the midpoint stuff. If we put a line through both of them, what that says is that those two objects are congruent. So there you have it. All right, so those are all the notes on segment addition postulate and congruency. We'll deal with theorems coming up a little bit later in our curriculum, but hope you found this video informative and easy to follow. Try the homework out next. You will find that on, online, and I will talk to you later.